C is a powerful and versatile programming language. It came into existence in the early 1970s at Bell Labs. Dennis Ritchie, a visionary computer scientist, created C. C was born out of a need for a language that was both efficient and easy to use. Before C, programmers often relied on assembly language. Assembly language is very low level. It requires writing code that is specific to a particular computer architecture. C provided a higher level abstraction. It allowed programmers to write code that could be more easily ported to different computer systems. C quickly gained popularity. It became the language of choice for system programming. The Unix operating system, a cornerstone of modern computing, was rewritten in C. This solidified C's reputation as a powerful and reliable language. C's influence continues to this day. It has served as the inspiration for many other programming languages, including C++, Java, and Python. C is a structured programming language. This means that C code is organized into blocks. These blocks are like paragraphs in an essay. Each block has a specific purpose. Structured programming encourages clarity. It makes C code easier to read, understand, and maintain. When programmers use structures, they break down complex tasks into smaller, more manageable chunks. This modular approach simplifies debugging. C's emphasis on structured programming promotes code reusability. Programmers can encapsulate specific functionalities within functions. These functions can then be called upon multiple times within a program or even in different programs. This reusability saves time and effort in development. Structured programming is fundamental to writing efficient, reliable, and maintainable C programs. It is an essential concept for programmers to grasp. C's support for structured programming is one of its key strengths. C is often referred to as a low-level programming language. This doesn't mean it's inferior. It means C gives programmers close control over computer hardware. With C, programmers can directly manipulate memory addresses. They can work with bits and bytes. This low-level access is crucial for system programming. Operating systems, device drivers, and embedded systems all require this level of control. C's ability to interact directly with hardware makes it incredibly powerful. It allows programmers to optimize performance. They can fine-tune their code to squeeze every ounce of power from a system. However, with this power comes responsibility. Programmers must exercise caution when working at such a low level. Errors in memory management can lead to crashes or security vulnerabilities. Portability is a cornerstone of C's design. C code is designed to be highly portable. This means that C programs can often run on different operating systems with little or no modification. This portability stems from C's relatively simple standard library. It also relies on the fact that C compilers are available for a wide range of hardware platforms. The ability to write code once and run it on multiple platforms is a huge advantage. It saves time and resources. It also broadens the reach of software. C's portability has undoubtedly contributed to its enduring popularity. While complete platform independence is often elusive, C comes remarkably close. This portability is a testament to the language's well-defined standards and the dedication of its compiler developers. Section 5. The C Standard Library, a treasure trove of functionality. The C programming language comes equipped with a powerful tool, the C Standard Library. This library is a collection of pre-written code. It provides a wide range of functions. These functions simplify common programming tasks. Need to work with input and output? The header file has you covered with functions like for formatted output and for formatted input. Dealing with strings? The header file provides functions for string manipulation, such as for copying strings, for concatenating strings, and for finding the length of a string. The C Standard Library is like a toolbox. It is full of well-crafted tools that programmers can use. This saves them from having to reinvent the wheel every time they write a program. By leveraging the functions provided by the C Standard Library, programmers can focus on the unique aspects of their applications. This leads to faster development times and more robust code. Section 6. Fundamental building blocks, the atoms of C programs. At its core, a C program is a collection of instructions that tell a computer what to do. These instructions are expressed using a set of fundamental building blocks. These building blocks include data types, variables, operators, control flow statements, and functions. Data types define the kind of values that can be stored and manipulated. C offers a variety of data types including got and for storing numbers with decimal points, floating point numbers. Variables are like containers that hold data. They have names that programmers choose, allowing them to refer to and manipulate the stored data. Operators perform operations on data. For example, the operator adds two values. The operator subtracts one value from another. The operator multiplies two values. The operator divides one value by another. Control flow statements dictate the order in which instructions are executed. Common control flow statements include statements which execute a block of code only if a certain condition is met, statements which provide an alternative block of code to execute if the condition is false, and loops which repeat a block of code multiple times. Functions are self-contained blocks of code that perform specific tasks. They promote code reusability and modularity. These fundamental building blocks are the atoms of C programs. They provide the essential tools for expressing computations and manipulating data. Section 7. A simple C program, from input to output. Let's illustrate the fundamental building blocks of C with a simple program. Hash include int main, int num1, num2, sum, print, enter the first number, scanf, %d, and num1. Print, enter the second number, scanf, %d, and num2, sum equals sign num1 plus num2, print, the sum of %d and %d is, %dn num1 num2 sum, return 0. This program calculates the sum of two numbers entered by the user. Let's break it down step by step. 1. This line includes the standard input-output library, which provides functions like for printing output and for reading input. 2. This defines the function, which is the heart of every C program. The code inside the curly braces is executed when the program runs. 3. This line declares three integer variables, and these variables will be used to store the numbers entered by the user and their sum. 4. This line displays a message on the screen prompting the user to enter the first number. 5. This line reads the number entered by the user and stores it in the variable. The format specifier tells to expect an integer input. 6. The next two lines prompt the user to enter the second number and read it into the variable. 7. This line calculates the sum of and assigns the result to the variable. 8. This line displays the final result showing the original numbers and their sum. 9. This line indicates that the program has executed successfully. This simple program demonstrates the basic syntax and flow of a C program. By understanding the roles of variables, operators, input, output functions, and control flow, you can build upon these foundations to create more complex programs. Section 8. Applications of C where C shines. C's combination of power, efficiency, and portability has made it a popular choice for a wide range of applications. System programming C reigns supreme in the realm of system programming. It's the language of choice for developing operating systems, device drivers, and embedded systems. Its low-level access to hardware and memory management capabilities make it ideal for these tasks. Game development C's speed and efficiency have also made it a mainstay in game development, particularly for performance-critical components like game engines and graphics rendering. Compiler development C is often used to write compilers and interpreters for other programming languages. Its ability to manipulate low-level constructs and generate machine code makes it well-suited for this purpose. Database systems. Many popular database systems, including MySQL and PostgreSQL, are written in C. Its efficiency and control over memory management are crucial for handling large datasets. Graphics and multimedia C is used in graphics and multimedia applications, from image editing software to video codecs. Its performance and ability to interact with hardware make it a valuable tool in this domain. C's versatility and performance have cemented its place in the software development landscape. It continues to be a relevant and in-demand language for a wide range of applications. Section 9. Advantages and disadvantages, a balanced perspective. Like any tool, C has its strengths and weaknesses. Understanding these advantages and disadvantages can help you make informed decisions about when to use C and when other languages might be more suitable. Advantages. Efficiency C is renowned for its efficiency. It's a compiled language, which means that C code is translated directly into machine code that can be executed directly by the computer's processor. This results in very fast and efficient programs. Flexibility C provides fine-grained control over system hardware and memory. This low-level access makes it incredibly flexible, allowing programmers to optimize performance and create custom data structures. Portability C code is highly portable. It can be compiled and run on a wide range of operating systems and hardware platforms with minimal modifications. Community support. C has a large and active community of developers worldwide. This means there's a wealth of resources, libraries, and support available online and in print. Disadvantages. Memory management. C requires manual memory management. Programmers are responsible for allocating and deallocating memory for their programs. While this provides flexibility, it also introduces the risk of memory leaks and other memory-related errors. Complexity. C's low-level nature can make it more complex to learn and use than higher-level languages, especially for beginners. Its terseness can lead to code that is difficult to read and debug. Security risks. C's manual memory management and low-level access can introduce security vulnerabilities if not handled carefully. Buffer overflows, for example, can occur if programmers don't properly check the bounds of memory buffers. In conclusion, C is a powerful and versatile language with a rich history and enduring relevance. Its efficiency, flexibility, and portability have made it a cornerstone of system programming and a popular choice for a wide range of applications. However, its manual memory management and potential for complexity require careful consideration. By carefully weighing its advantages and disadvantages, you can determine if C is the right tool for your next programming project.